Midterm is 41 questions, all multiple choice. So midpoint formula is x1 plus x2 over 2, comma y1 plus y2 over 2. So it's like the average of the x's and the average of the y's. You also need to know your slope formula. So slope is y2 minus y1 over x2 minus x1. And then for an equation of a line in point slope form, that would be y minus y1 is equal to m times x minus x1. And then in slope intercept form, it's y equals mx plus b. One more. I don't know if we're going to give this to you or not, but just in case, your arc length. S is equal to r times theta. And what does theta have to be in? Radians. So if it gives it to you in degrees, you'll have to convert it. Make sure you know how to convert. I'm not going to put that on formulas you need to know because that should be easy. We'll practice converting. One more. Quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. So let's do the review. Looking at 1, it says evaluate the indicated function. We're looking for f minus g, so we take our f and subtract g. So f minus g, I'll call it of x to start, because we're just going to leave x's in there for now, would be x squared plus 2 minus x minus 3. When you subtract, make sure you plug it into parentheses, because next thing we would have to do would be distribute the negative. So this would end up being x squared plus 2 minus x plus 3. So when you're subtracting, don't forget to plug it in parentheses, because everything after it's going to turn negative. To find f minus g of 4t, we're going to take 4t and plug it into all of our x's. So we have 4t squared. I'm going to kind of do 2 steps in one. I'm going to combine my like terms, but minus 4t, and then 2 plus 3 would be plus 5. Last step is this would be simplified. So don't forget, square the 4 and square the t. So this would be 16t squared minus 4t plus 5. So that would be our answer. The answers for the review are posted on Canvas. We're not going to have time to do every single question from the review, so you can just look back at the answers, but I'm going to try to do a little bit of everything. For number 2, f of g, so we're going to take g and plug it into f. So you always take the second one or the one on the inside, put that inside your other function. So I'm going to take g and plug it into the x in f. So f of g would be the square root of x to the 5th power plus 2. Midterm is multiple choice, so if this was a question that could be simplified, the answer choices would probably be simplified, but here we can't simplify it anymore. So just always look back at your answer choices, kind of see how simplified do the answer choices leave it. Use your answer choices to help you. For number 3, we want to find the inverse. To find the inverse, we're going to switch x and y, and then solve for y. So I'm going to change, f of x is just a fancy way of saying y, so I'm going to make that x, and I'm going to change x to be y. So we have x minus 6 is equal to the square root of 2y. Just move the 6 to the other side. We're trying to get y all by itself. How do I get rid of the square root? Square both sides. So I'm going to square this side and square this side. So it's going to cancel. On the left side, I'm just going to leave it as x minus 6 squared. Again, look at your answer choices. It might FOIL it out. So if it does, if your answer choice doesn't look like the x minus 6 squared is left like this, write it twice and FOIL it out. But we're going to leave it because I think it would probably be left just like this. So that's equal to 2y. And then divide both sides by 2. So x minus 6 squared over 2 is equal to y. This would be our inverse. For number 4, it says determine if the function's even, odd, or neither. So for this, we want to plug in a number and its opposite. If we get the same number, then it's going to be even. If we get opposite answers, meaning that one's positive and one's negative, same number, but one's positive, one's negative, then it would be odd. And if we get totally different numbers, then it's neither. So a good number to plug in would be like 2 and negative 2. So here we have the cubed root of 2 minus 6. So that'd be the cubed root of negative 4. Then we have the cubed root of negative 2 minus 6. So the cubed root of negative 8. Are these the same number? Are they the same number but opposites? No, they're totally different. So this would be neither. For number 6, when we find the domain, 2 things we have to check for. If we have a fraction, so if I had like 1 over x, the denominator cannot be 0. So we'd set the denominator not equal to 0 and solve for x. If we have a square root, we can't have negatives under our square root. So we'd set whatever's under greater than or equal to 0. And if we have a square root in our denominator, we'd set whatever's under the square root just greater than 0. Because it can't be equal to if it's in the denominator. So these are the 3 rules that we have to check for when we're checking the domain. So for something like 6a, to find the domain, we'd set the denominator not equal to 0 and solve. We'd subtract 1 on both sides, so x squared does not equal negative 1. Square root. X does not equal, can I take the square root of a negative? What would we get? What's the square root of negative 1? I. It'd be imaginary. Well, the square root of 1 is 1, but it'd just be I. This is imaginary. So you're not going to have imaginaries in your domain. So because x cannot equal an imaginary number, it's not real. This would be all real numbers. Or it'd be from negative infinity to positive infinity. These mean the same thing. It's multiple choice, so you might see it one way or the other, but they're the same. All right, let's look at b. So for b, since we have a square root, we know that what's under our square root cannot be negative, so we'd set it greater than or equal to 0 and solve. So x squared is greater than or equal to 16 when we add 16 to move it to the other side. Take the square root, so x is greater than or equal to what?
4.
Just 4? Plus or minus 4. If you take the square root of both sides, you need plus or minus. So because we have 2 values here, let's put it on a number line and figure out, are we talking about in between negative 4 and 4 or outside of these numbers? So negative 4 and 4. We can test a number in between, so I'd pick something like 0 because that'll be nice and easy to plug in. If I plugged in 0, I have 0 minus 16. Can I take the square root of negative 16? No, we can't take the square root of a negative. Can't have a negative under our square root. So it does not work in between, so that would mean it would work outside. So here, our answer would probably be from negative infinity to negative 4 with a bracket because it's greater than or equal to, and then from 4 to infinity if it wrote it in interval notation. For 7, determine whether the line passing through the points are parallel, perpendicular, or neither. So parallel means that they're going to have the same slope. Perpendicular means that it's going to be opposite reciprocal slopes. So an example of opposite reciprocal would be if we had like 3 over 4 and then negative 4 over 3. And then neither would just be that they're totally different. So we'd have to find the slopes of both of these, see if we get the same number or opposites. We'll practice finding the slope. So our slope formula, that's one you guys got to know. y2 minus y1 over x2 minus x1. So I'll call this x1, y1, x2, y2. I'm going to go through this kind of quickly because I hope you guys have already looked at the review, but you should know how to find the slope. 0 minus negative 4 over 7 minus 2. We get 4 over 5. Do the same thing for line 2. I'll call this x1, y1, x2, y2. So 0 minus negative 8 over 14 minus 4 would give us 8 over 10, which simplifies to 4 over 5. So if both of our slopes are 4 over 5, what does that mean that our lines are? Parallel, perpendicular, or neither? Parallel, because we have the same slope. Parallel. It should be. Just making sure you guys were paying attention. That's what happens when I rush through these. This is 4 minus 14. So this would be 8 over negative 10, which actually throws off our answer. So it simplifies to 4 over negative 5. Are these the same, opposite reciprocals, or neither? Neither. So it changes it from being the same to now neither. Remember, opposite reciprocals would be if it flipped and if it was negative. If one was negative and one was positive. Yeah. All right, 8, determine the x-intercepts. Set it equal to 0 and solve. What would I do first to solve here? Divide by 2, awesome. Let's take out our GCF. We're going to divide everything by 2. Since we're setting it equal to 0, 0 divided by 2 is just 0 still, so we can just get rid of it. X squared minus 2x minus 8 is equal to 0. What are two factors of negative 8 that add to negative 2? Negative 4 and 2, perfect. So x minus 4 and x plus 2. X is equal to 4 and x is equal to negative 2. If it asks for x-intercepts, it would probably be written as coordinate points. But as long as you know how to find them, you'll be fine. Remember, it's multiple choice. So we would have 4, 0 and negative 2, 0. Number 9, find the zeros and state the multiplicity. So here we would set it equal to 0 and solve. This factors, when we have 4 terms, how would we factor? Grouping. So we can group them. If we had something like this that doesn't factor, one thing we could always resort to is doing last over first. So factors of our last term over factors of the first. I'm going to practice it this way just in case we have something that doesn't factor on the test, because I feel like you guys are good with grouping. So factors of our last would be 1 and 20, 2 and 10, 4 and 5. That's it. Over factors of the first would just be plus or minus 1. When we do last over first, we're going to do synthetic division. Our goal is to get the remainder to be 0. If the remainder is 0, that means that what we divided by is going to be one of our zeros of, or one of our solutions of our polynomial, of our function there. So let's do synthetic division. Inside the box, we have 1, negative 5, negative 4, and 20. Outside the box, we can try any one of these possible options. So let's try 2. You can try anything. Drop down the 1, multiply, we get negative 3. Negative 6, negative 10. Oh, that's so nice, it works. We get 0. So one of our answers would be 2. From here, since we start with x to the third power, our answer gives us 1 less. So that would be x to the second power minus 3x minus 10. From here, we could factor if we wanted to. You could still do last over first, but then you're trying out what works, what doesn't work. It's just going to be easier to factor. So 2 factors of negative 10 add to negative 3 would be negative 5 and 2. So x minus 5 and x plus 2. So on our list, we have 5 and -2. So these would be our zeros or our solutions. At each one of these points, the multiplicity is how many times you have that number as your answer. Each one of these are different. We don't have anything that repeats, so these would all have a multiplicity of 1. Just one more thing to practice here. If this asked us to graph it, we know that our x-intercepts are going to be 2, -2, and 5. So I would put a point at 2, point at 5, and a point at -2. This is where I cross the x-axis. Our end behavior, since it's odd, is going to go in opposite directions. And because x cubed is positive, it's going to have an increasing slope overall. So our left arrow is going to go down, the right arrow is going to go up. And then in between each point, we just connect the dots. So our graph would look like this. Remember, it's multiple choice, so use your answer choices to help you. You can use process of elimination when it comes to graphing. If you know how to find the end behavior of it and you know what your end behavior looks like, you could probably eliminate half of the answer choices right there. For a question like number 10, when we find the slope and the y-intercept given our line, we're just going to rewrite this into slope-intercept form. So y equals mx plus b. We just need to do some rearranging. So I'm going to add y to move it to the other side. You can move it the other way if you want to. So we got 4y is equal to -8x plus 16. Just be careful with your signs when you're rearranging. Then we want to divide everything by 4. So y is equal to -2x plus 4. So what's our slope? And what's the y-intercept? 4. Awesome. -2 is our slope, 4 is the y-intercept. It did. Here are our vertex questions. So if we had something like y equals x plus 5 squared plus 2, what would our vertex be? -5 comma 2. Perfect. If it was written like 11 or 12 where it starts in standard form, to find our vertex, we would use -b over 2a to find the x from our vertex, or the h, and then plug that in to find y. Our vertex form formula is y equals a times x minus h squared plus k. So this would kind of be our h, and this is our k, or our x and y, but because it's the vertex, it gets a special h and k. And then a would come from our standard form. So this is a, b, and c. A, b, and c. So 11 and 12 are super similar. (13), same idea. Plug it into your formula here. Your vertex is going to be the h and k. The point is your x and y.
Mateo Bernard, please report to student services. Mateo Bernard, thank you.
For 14, find the vertical and horizontal asymptotes. To find the vertical, you set the denominator equal to 0. To find the horizontal asymptotes, we look at the degrees. So for A, our vertical asymptote, set it equal to 0. X would be -2 over 5. For our horizontal asymptote, we look at the degrees of our highest degree of the numerator and the denominator. When they're the same, we look at the coefficient. So our horizontal asymptote would be y equals 3 over 5. Our rules for horizontal asymptotes, if they're the same degree, so let's say I had 2x squared over 5x squared. they're the same, look at the coefficients. So our horizontal asymptote would be y equals 2 over 5. If the numerator is higher than the denominator, if we had like x cubed over x, then we would have no horizontal asymptote. If our denominator has a higher degree, let's say we had x over x squared, our horizontal asymptote would be y equals 0. So these are the rules for the horizontal asymptotes. For a question like 16, typically what we would do is, since negative 3i is a 0, we know that positive 3i is also a 0. It's conjugate pair. So then we would know that x minus 3i and x plus 3i would be factors of it. So you can FOIL these out and then divide your polynomial by it. My suggestion would be use your answer choices and work backwards. So if my answer choices, I'm not sure what the answers are, but let's say our answer choices were negative 3i, positive 3i, because we know that those are zeros, and 4 and 5. I made this up, but let's say this is answer choice A. Answer choice B. I could test 4 and 5 and see if those work as zeros. So I would do synthetic division. Whatever gives me 0 as the remainder would be one of my answers. So working backwards for a question like this would probably be less time than FOILing these out, making sure you don't make a mistake, then using long division and finding your remaining zeros by factoring. I think working backwards, use synthetic division, test your answer choices and see what works. Does that make sense? Questions here? So for a question like 17, if the question said solve using long division and it was just dividing by something like x plus 2, where we could use synthetic division, use synthetic division. I'm not going to go back and look at your work. Just find the answer however you need to find the answer. For this question, though, since it's dividing by a trinomial, you can't use synthetic division. So we'd have to use long division here. So let's practice long division. Outside the box, we've got x squared minus 5x minus 1. Inside the box, 5x cubed minus 21x squared minus 25x minus 4. Always make sure when you're doing synthetic division or long division, you're not missing any terms. I have every term represented here. I've got x to the third power, x squared, x to the first power, and negative 4. We're not missing anything. We can go ahead and start dividing. When we do long division, there's 3 steps. We divide. Step 2 is multiply. Step 3 is change the signs and combine. So when we divide, 5x cubed divided by x squared would be 5x. I'm going to write that on top of my x term just so I'm nice and organized, keep everything in line. 5x times x squared would be 5x cubed. 5x times negative 5x would be negative 25x squared. And 5x times negative 1 would be negative 5x. Change the signs and combine. 5x cubes cancel. Negative 21x squared plus 25x squared would be 4x squared. Negative 25x plus 5 would be negative 20x. Do the same thing again. So we're going back to the top. We're going to divide. 4x squared divided by x squared would be 4. Then we take 4, we're going to multiply that times everything out front. So 4x squared minus 20x minus 4. Change the signs and combine. 4x squareds cancel, 20x's cancel, and the 4's cancel. So this would be our answer. If we had something left over, that would be our remainder. It could be written as a fraction, or it could just say remainder, whatever. Let's say hypothetically our remainder was 10. If we added these together and got 10. Let me change the color because this is hypothetically. So depending on how your answer choices are, it might say remainder 10, or it might write it as plus 10 over x squared minus 5x minus 1, like that. You could see it either way. Here we don't have remainder. This is made up. 18, use the remainder theorem and synthetic division to find the value of the function. So inside the box, we're going to put our coefficients 2, 11, negative 21, negative 90. Outside the box, since it just says f of negative 6, it's telling us negative 6 is what we plug in, so negative 6. If it said x plus 6, this is where we change the sign when you use synthetic division. If it said x equals negative 6, you don't change the sign. So you would only change it if it was written like a binomial. When it says use remainder theorem, whatever the remainder is your answer. Just the remainder. It's going to be kind of obvious because it's multiple choice. So it's not going to give you the whole polynomial as one of your options. It's just going to be numbers for each one. So whatever the remainder is, that's your answer. Do you want to practice using synthetic division, or we feel good with this? Good? Okay. For 19, show that x is a solution and then factor completely. So to show that x is a solution, we do synthetic division. Inside box, 1, negative 1, negative 9, negative 9. Outside the box, since it says x equals, we're going to put 3. If it's a solution, we're going to end up with 0 as the remainder. 0 means that it is a solution. If it was something other than 0 as your remainder, it's not a solution. Then since we started with x to the third power, our answer here would be x squared. From here, you would factor to find the remaining zeros. So given x minus 4 and x minus 3, find the remaining roots, write fully in factored form. So we can break this down into something smaller by dividing these two. So here x would equal 4 and x would equal 3. So we're going to write our coefficients inside the box, 1, negative 5, negative 2, and 24. We can put 4 outside. It tells us that it is a root, which means that it's a factor, it's a 0. This is the same thing as saying find the zeros. So we're going to end up with 0 as our remainder, but let's do it and we'll break it down. So drop down the 1, multiply, we get 4, add negative 1, multiply negative 4, negative 6, negative 24, 0. So 4 works. It also tells us that x equals 3, so we know that this one's going to work too. So you can use synthetic division here also, or since we know that we started with x to the third power, this is x squared minus 1x minus 6. You could just factor from here. Either way works. Since it gave you 2 of the answers, you can plug in 3 also. Use synthetic division with 3. But let's factor it just to practice. 2 factors of negative 6 that add to negative 1 would be negative 3 and positive 2. So x minus 3 and x plus 2. So x is equal to 3 and x is equal to negative 2. And we know that x equals 4. So 21. What happens when we multiply by a negative on the outside? Reflection. On which axis? X-axis, awesome. When we multiply by a number outside, this would be, since it's greater than 1, it's a stretch. What about when we add on the inside? Left 4. I think about it because, this is how it makes sense in my brain. You guys can make sense however you want. But left kind of has like 2 plus signs. So plus means that it's going to go to the left. Even though kind of right has a plus sign too with the T, but this is how I remember. Remember it however you want. -1 goes which way? Down. 22, write the equation in its equivalent form. This is asking us to go either from exponential to log or from log to exponential. Since it starts in exponential here, we're going to rewrite it in log form. So I start with log. Whatever has the exponent, that's my base. The other two numbers switch position. So log base 4 of 64 is equal to 3. Same thing here. I'm going to start with log base 5. The other two numbers switch position. So log base 5 of 1 over 125 is equal to -3. For C, we're putting it into exponential form. So whatever the base is of my log, that's going to start as my base. The other two numbers switch positions. So 4 to the power of 3 equals 64. This one's missing an exponent, but we'll call it 1. Actually, we'll call it x because 1 doesn't really make sense. So 5. Just kidding, it's not missing an exponent because it's in log form. We'll call this x. Log base 5 of x. So 5 would be our base. The other two numbers switch positions. 5 to the power of 3 equals x. For something like 23, I would maybe start by finding our x and y intercepts. It's multiple choice. Use the answer choices, process of elimination. Use the answer choices to help you. So to find the y-intercept, where we cross the y-axis, plug in 0 into x. So I'm going to change g of x just to be y. So y equals -3 to the power of 0 plus 2. What's -3 to the power of 0? It'd be 1. So y is equal to 1 plus 2 would be 3. So our y-intercept would be 0, 3. So we're going to cross the y-axis at 3. So we know that this point is on our graph. If we knew nothing else about the shape of our graph, that's a good place to start. That would probably eliminate most answer choices. You could even plug in 1 and find out what your graph looks at 1. Let's do that too. So y equals, when we plug in 1, -3 to the power of 1 plus 2. -3 to the power of 1 would just be -3. So -3 plus 2 would be -1. So here are our points. Since we plugged in 1, we got -1. So we're going to go to the right one and down to -1. Yeah, I think because I assumed that this was parentheses, but it's not. Let me fix that, then I'll redraw it. If it's not parentheses, it's just 3 to the power of 0, which would be 1. So that would make this -1. So -1 plus 2 would be 1. So our y-intercept would be 1. So I'll draw both of our points again. 0, we go up 1, and then we go to the right one and down 1. So again, if we knew nothing about the shape of our graph, this helps. It's probably be enough to even pick the answer. Since it's an exponential function, typically our exponential functions look like this. we have a reflection here, so it flips it the other way. So our graph is actually going to look like this. If you kept plugging in numbers, you'd see more of a shape. But maybe I think even just plugging in 2 values would help you pick your answer. Yeah, so the negative's outside, so it was just 3 to the power of 0. That negative stays there. All right, let's look at 24. Determine the zeros. When you have a fraction, you just need to set the numerator equal to 0. If you set the whole thing equal to 0, that's fine too. You can cross multiply. When you multiply the denominator by 0, it goes away anyways. But we just need to set the numerator equal to 0 to solve. We can divide by 2. X squared equals 0. Take the square root. What does x equal? 0. 25, we want to write the quotient in standard form. So we want to multiply by the conjugate of our denominator. I'm going to rewrite our denominator in standard form. I'm not changing any of the value of it. I just flipped the 2 numbers, saying 2 plus 4 is the same as 4 plus 2. I just switched them. This way we can multiply by our conjugate, which is 3 minus 3i. Whatever we multiply to the bottom, we also have to multiply to the top. On the top, we're going to FOIL it out. So we get 15 minus 15i minus 12i plus 12i squared. Let's simplify the top before we move on. What can I change I squared to be? -1. So that changes this to be a minus 12. Then when we combine our like terms, 15 minus 12 would be 3. And then negative 15i minus 12i would be negative 27i. So that's what we got up top. On the bottom, you can FOIL it out, or since they're conjugates, you can use your conjugate shortcut. A squared minus b squared. Either way works. If you're not comfortable with your conjugate shortcut, FOIL it out. So this would be 9 minus 3i squared. I'm going to write that out so we see it. 3i squared. Don't forget, you have to square the 3 and square the I. So this would be 9 minus 9i squared. What does I squared change to? -1, which makes this a plus 9. So 9 plus 9 is 18. We can actually simplify this a little bit more because all 3 of our numbers are divisible by what? 3. So because all 3 numbers are divisible by the same thing, we can simplify. If they weren't, if all 3 numbers weren't divisible by the same thing, you could not simplify. So we got 1 minus 9i over 6. That would be our answer. Yes. For 26, multiply. You cannot distribute the squared. Write it twice and FOIL it out. So 7 minus 5i times 7 minus 5i and FOIL. For 27, we're going to solve. So when it's in exponential form, we either want to see if we can make the bases the same. If we can't, you can put it into log form to get that x out of the exponent. So when we put it into log form, our base is 5, log base 5. The other 2 numbers switch positions. So log base 5 of 3x is equal to, log base 5 of 6 equals 3x. Then we'd put this into the calculator. If your calculator does not change the base for you, we'd have to use our change of base formula. So log of 6 over log of 5 equals 3x. Find what this is in the calculator and then divide by 3. 28, find the x-intercept. X-intercept, plug in 0 for y.
I'm so sorry. You must go back to 27.
Yeah. I'll leave it there. So 0. For this question, for A, we may want to change it into log form. ln is the same as log base e. So if this was log base e of x minus 7 equals 0, when it's in log form, change it to exponential form. So you can either make the big base e on both sides, this will cancel, or just rewrite it into exponential form. E to the power of 0 equals x minus 7. What's e to the power of 0? 1. So 1 equals x minus 7. Add 7, move it to the other side, x is equal to 8. Same thing with B. Make y 0 when we find the x-intercept. Put it into exponential form. 2 to the power of 0 equals x minus 2. Same. All right, let's do 29. If we have a log equals a log, you can cancel them and just set 5x minus 7 equal to 2x plus 5. And then solve for x. Combine your like terms. You guys know what to do from here. That's what I thought. So for our vertical asymptotes, just set the parentheses equal to 0. X plus 3 equals 0, so x is equal to negative 3. Our log graph looks like this, or it could look, if it flipped, it could look like this. Or if we had a reflection on the y-axis, it would flip to go the other way. But here we don't have a reflection, so our domain would just be from negative 3 to infinity, because it's going to the right. All right, 31 and 32. Well, 31, log base 9 of 9, these cancel. This is equal to 1. It equal to whatever your exponent is. Here it's just implied that our exponent would be 1. But if we had, let's say, log base 5 of 100, log base 5 of 5 cancels, we'd be left with 100. Convert to radians. We multiply by pi over 180. Here you can use your calculator to simplify. 5 goes into 225 and 180, so you can divide them both by 5. I don't have my calculator on me, and I think that you guys could handle it from there. 33, convert to degrees, multiply by 180 over pi. Pi's cancel, 6 goes into 180 30 times. We'd multiply 11 times 30. 34, find one positive and one negative coterminal angle. Coterminal, if we're talking about degrees, we'd add or subtract 360. For radians, we would add or subtract 2 pi. So depending on what your angle is that you start with, you can add or subtract 360 or 2 pi as many times as you need to find a positive and negative one. Use your answer choices to help you. Keep adding or subtracting until you match your answer choices. 35, find one complement and one supplement of the given angle. Complement are either going to add up to 90 or they'd add up to pi over 2. Supplement, add up to 180. Or they'd add up to pi. So here you always take the 90 and subtract the angle for the complement. Complement and supplement are always positive. You're looking for 2 positive angles that add or subtract. So for A, we wouldn't have a complement because there wouldn't be a positive angle that adds to 104 that's going to equal 90. All right, 36, find the arc length of the sector with the given info. S is equal to R times theta is our arc length formula. You need to know this. And we said that theta has to be in radians. So here I'd want to convert 225 into radians, so I'm going to multiply by pi over 180. I guess we'll simplify it now to work it out. 5 goes into 225 45 times. 5 goes into 180 36 times. 9 goes into 45 and 36. I don't know why I put degrees. So let's divide them by 9. 9 goes into 45 5 times, and 9 goes into 36 4. So this would be 5 pi over 4 would be our theta. So S is equal to R times theta. We have 6 times 5 pi over 4. So S is equal to 30 pi over 4. This simplifies to 15 pi over 2. (37), we're doing the same thing. S is equal to R times theta. But here we're looking for theta. It doesn't tell us what it is, but we'll plug in S and R. So S is 8 is equal to 6 times theta. To solve for theta, we want to get it all by itself, so we're going to divide both sides by 6. So theta is equal to 8 over 6, which simplifies to 4 over 3. (38) is kind of similar to what we've been doing. (-9) would be our x, 12 would be our y. How would we find r? Pythagorean theorem. Use Pythagorean theorem to find r. We know that cosine is x over r. So once you have your r, just put (-9) over r. Cosecant is the reciprocal of sine. Yeah. So this would be r over y. Any questions there? We just did that in the last chapter. So it should still be pretty fresh. 39, we want to solve. So back to logs. We always want to get the base and the exponent all by itself. So here I would divide 4 to move it to the other side. 8 to the power of x minus 1 is equal to 8. When our bases are the same, we can cancel them out. What's the exponent on 8 implied? 1. Awesome. So 8's cancel. X minus 1 is equal to 1. Add 1. X is equal to 2. 40, we're expanding our log. So every time we break it apart, each one needs its own log. So log base 7 of 40, x cubed. I'm just going to do one step at a time. What goes with the division? Subtraction goes with division. So subtract log base 7 of z to the 5th power. Here, I'm multiplying 40 times x cubed. What goes with multiplication? Addition. So log base 7 of 40 plus log base 7 of x to the 3rd power minus log base 7 of z to the 5th power. And then what would I do with the exponents? I'd put them right in front of the logs that they are attached to. So my final answer would be log base 7 of 40 plus 3 log base 7 of x minus 5 log base 7 of z. For 41, we're condensing. So we're doing the same thing but opposites. So when we are adding, we multiply. And then I also want to move my coefficients up top. So this would be log base 8 of x plus 3 to the 5th power times x minus 6 to the 1/3 power. It's multiple choice. It probably won't be written to the 1/3 power. It might be written like x plus 3 to the 5th power times the cubed root of x minus 6. So these are the same thing. The answer choice would probably be written like the cubed root and not the exponent there. Any questions here? Good here? For 42, state the quadrant where theta lies. Here we need to know all students take calculus. If sign is greater than 0, it means that it is positive. So we can eliminate the tangent quadrant and the cosine quadrant, because sine's just going to be positive in the all and sign. If secant is less than 0, secant goes with cosine, so cosine would be negative if it's less than 0. So it's not going to be in the all positive. So we are in the S quadrant, which would be which quadrant? Quadrant 2. 46. Here we want to solve by factoring. How would we factor when our leading coefficient is not 1? What do we do first? Multiply the first times the last. We get negative 12. What are two factors of negative 12 that add to negative 1? Negative 4 and positive 3. So e to the power of x minus 4 and e to the power of x plus 3 equals 0. What do I have to remember to do next? Don't forget to divide by 2. If you start by multiplying the first times the last, you have to remember to divide. People are still forgetting to do that. We've had a question like this on almost every single test where you have to multiply the first times the last to factor. People are still forgetting to divide. So this would be e to the power of x minus 2 and 2 e to the power of x plus 3 equals 0. To solve, we'd set them both equal to 0. E to the power of x minus 2 equals 0. And 2e to the power of x plus 3 equals 0. So e to the power of x equals 2. Subtract 3, we'll solve them both here. 2e to the power of x equals negative 3, divide by 2. E to the power of x is equal to negative 3 over 2. How would I find x? What cancels out the e? ln, awesome. We take the ln of both sides. So ln of e cancels. We're left with x equals whatever the ln of 2 is in our calculator. Same thing with the other one. We'd take the ln of both sides. Can we take the ln of a negative? No, you can try in your calculator. It's going to say error. So this doesn't give us any answer. So it would just be x equals whatever the value of ln of 2 is. You can put it in your calculator to find out. 47 is also similar to what we just did on the last test. Sine of theta is equal to square root 10 over 4. Square root 10 is our y, and 4 is going to be our r, because sine is y over r. How would we find x? Pythagorean theorem. Awesome. So x squared plus square root 10 squared is equal to 4 squared. This tells us cotangent is greater. This should be a 0, not a theta. Cotangent is greater than 0. Yeah, so that tells us what quadrant we should be in. All students take calculus. Sine is positive, so we can eliminate tangent and cosine. Cotangent goes with tangent. So if tangent is greater than 0, it means that it's positive. What quadrant are we in? The first one. Everything's positive. So we'd be in quadrant 1. So that tells us that our x is going to be positive also. So we would just find x, and I think here it would specify what angle it's looking for. Or you could find them all. Keep in mind, sine is y over r, cosine is x over r. What's tangent? Y over x. And then we have our reciprocals. So cosecant would go with sine, so that would be r over y. Secant would go with cosine, so r over x. And then cotangent goes with tangent, so that would be x over y. Last part of the review. Make sure, I would definitely practice the last test and quiz review. You're going to have your questions that ask you to simplify, so you'd use your trig identities. So trig identity, I'll make a list here. Simplifying and verifying goes with the trig identities. 47. We had a question similar on the last test, but it gave us something like actually, it'd be something similar to 47, so that's already on there. Solving our trig functions. So if we had something like sine of 2x is equal to 1/2. You can't see that color on there, can you? Not really. We'll practice this. Sine of 2x is equal to 1/2. This was on our test. What would we do? What do we do? Look at our unit circle. We would want to see. Look at unit circle. Sine, we look at what value? The y. We would want to see what y value is 1/2. I think that it is pi over 6. I don't have the unit circle in front of me, but we're going to say pi over 6 is one of our options. We'd set 2x equal to pi over 6. What would we do next to solve? Divide by 2. So we'd divide both sides by 2. Here we'd have to change flips. We'd multiply by 1/2. So this would be pi over 12. This would be one of our answers. I don't have the unit circle in front of me to find the other one, but this would be an answer. We'll do one more because I don't think we had a question like this on the review. Let's say y equals 4 times x plus 2 squared minus 10. What would our vertex be? What would our vertex be? So it comes from what we're adding on the inside and what we're adding on the outside. But you have to change the sign of the inside. So it'd be -2, -10.